Okay, now question number 5 says the binomial 64x squared plus 256 is a sum of squares that can be factored. Why is this going to be possible? Now, we cannot factor a sum of squares like we factored a difference of squares, right? So what we have to then do is see if we can factor out a least common factor here. So we need to look and see if we can see if something's in common. So we want our greatest common factor. Now, when we look at 64 and 256, we need to see if we can factor something out first. We can't factor it as a sum of squares, because sums of squares do not factor. Only differences do. But we can look and see if we can take a variable out or if we can take a number out. And it looks like they both have something in common. And let's see if 64 is in common with both of them. I think it is. Yep, both of these have a 64 in common. So what we can do is we can take out our greatest common factor of a 64. And that's going to then leave you with x squared plus 4. Now, can we go any further? No. Why not? Because it's a sum. If this was a difference, we could factor it as a difference of squares. But that's all we can do because of the sum. So it says, why is this possible? It's possible that we can factor it because we can still take out a greatest common factor. So we can take out a greatest common factor of 64. Okay, so that's what I was wanting you to see on that one. And if it would have been a difference, we could go quite a bit further. But it's not. It's a sum, and sums can't go any further down. And that's question 5. Let's now look at 5-4. And we've got a few questions that I picked out of 5-4 to look at. And I tried to pick several of the different types just so we would be aware of all the different ones that you may encounter. So question 2 out of 5-4. 5-4 is all the different factorings put together. So the first thing whenever we look at these in 5-4 is we need to figure out how do we approach a problem like this. And the first thing that we always do before anything else is we see if we can factor something out. Okay, so before we do anything else, before we try and factor this at all any other way, we look at all the terms in a holistic way with the variables, and we see what we can factor out. Now, when it comes to variables, what do? We always factor out the lowest one. Now, these all have a z in common. Okay, so I've got a z. And what's the lowest power of z? Well, it's a z squared. Now we look at all the numbers. We've got a 45, we've got a 45, and we've got a 48. Well, let's see if we can take a 3 out of that 48. Okay, so 3 goes in there, right? Let me get the other calculator so it's easier to see. So we'll start with that 48, and we'll try a 3. Okay, 3 goes in. 3 goes into all of them. Now, there might be more. Let's try a 9. I don't think 9 will, but you need to make sure you get the highest one possible. And, of course, 9 does not work. Right? Won't go in there. 5 doesn't go in there. These have a 5 in the end. 5 doesn't go into 48. So it looks like the highest number that's in common with all of them is going to be a 3. So we're going to factor out a 3z squared. Very, very first thing you do before any other type of factoring is applied, you look and you see if something's in common. So now we just divide. So we've got 45. We're going to divide that by 3. And that leaves you with a 15. We've got z to the 6th, taking out 2 of them. That leaves you with a z to the 4th. And we've got a minus. Then we've got 48. We're going to divide that by the 3. And that leaves you with the 16. Z to the 4th, take out 2 of them. That leaves you with the z squared. And we still have that minus 45 divided by 3 again. That's a 15. And the z's completely are gone. So now we've reduced the numbers down a bit, so they're smaller. And now we need to figure out how to factor this. So now once we've taken out that greatest common factor, now is when we have to figure out and determine what technique we apply. Now the technique that we apply is going to be based upon the number of terms that we have. So 1, 2, 3 terms. Whenever we have 3 terms, we take the first number and we multiply it by the last number, and we're going to split up the middle. So we take the first number times the last number. So 15 times 15. 1 negative, we keep it as a negative, so that's going to be a minus 225. Then we look at our number inside that box, and we look at the sign of that number. So that sign is negative. So since it is negative, that means 1 is positive, one of the numbers is negative. And then we move back to our polynomial here, our trinomial specifically, and we look in the middle, and the middle is negative. So that tells me the smaller number is negative, larger number is negative, smaller number is positive, because the middle is negative. And now we need to divide and try to figure out what 2 numbers are going to work. Now when I look at 225, what do I know? It ends in a 5. So we're going to start with multiples of 5, and we'll eventually find it. So let's try 5. 225 divided by 5. Okay, that's 5 and 45. That's a difference of 40. We want a difference of 16, so not going to work. Okay, 10 does not go in there, right? How about 15? Well, 15 doesn't work either, because 15 and 15, that's a difference of 0. Let's try 20. Doesn't go in there. Let's try 25. Okay, 25 and 9. Now, what about 25 and 9? Well, 25 minus 9 is what? 25 minus 9 is 16. So that's going to work. That's going to be our 2 numbers. Negative 25, positive 9. So how did I know where to begin on these numbers? I looked at the number inside the box, and I noticed that number ends in a 5. If it ends in a 5, it has to have a multiple of 5 in it. So you continue to try multiples of 5, like 5, 10, 15, 20, 25 eventually, and you will find the number. Sometimes you can just see the numbers. Other times you'll want to use a calculator, and you know it ends in a 5, so it has to have a 5 in there. And just try multiples of 5 until you get it. Now what do? Now we take the middle and we split it up. So we keep the 15z to the 4th. We take that minus 16z squared, and we split that up into minus 25z squared and a positive 9z squared. And then we bring down our minus 15. So that's how we handle 3 terms. First time's the last, split up the middle. Now we factor by grouping. So now when we look here, we see that these have a 5 in common, it looks like. So we're going to take a 5z squared out. And that leaves me then with a 3z squared minus 5. Repeating the process on the next 2. These have a 3 in common. And that is going to then leave me with a 3z squared minus 5. My groupings are identical. So that leaves me then with 3z squared minus 5. 5z squared plus 3, and do not forget what's out in front of all of it, is a 3z squared. That is your final, fully factored, finished answer. Now, how do we know that that is where we stop? Well, we look at each part and we make sure we can't go further. 3 and 5 have nothing in common, so this cannot be factored. This one can't be factored. We make sure we brought that 3z squared out. That is as far as we can go. So always check the parentheses. If nothing comes out, that's when you know that you are finished. Question 4, we just want to factor this trinomial out here, this polynomial. Polynomial is classified as everything. Trinomial is a specific one. This one's a trinomial because it has 3 terms. And we want to factor that, and we want to explain the method we're going to be using. So all I really want you to do on question 4 is just simply factor it. So if I gave you this question to factor, which is 5a to the 4th plus 34a squared minus 7, and I said factor this, how would you factor this? Well, first thing we always do is what? We look to see if any number or variable is in common with all the parts. Nothing's in common. So that's step 1. Take out that greatest common factor if you can. There is not one in this case. So we want to factor this. Now, how many terms does this have? 1, 2, 3 terms. For 3 terms, what do? We take the first times the last, and then we split up the middle. So this is how we would factor it. All I want you to do is just tell me how you're factoring it, and you can do that just by factoring it down. So first times the last is a negative 35. Now, we know that this is negative, so what does that tell you? One positive number, one negative number. When you look in the middle, it's positive. So positive number is larger, negative number is a smaller number. Always look for patterns and try to look ahead and see what numbers I think I can use to start with. So, to make your life easier, instead of trying a whole bunch of different numbers, I look at the 35 and I'm going to compare it to 34. 35 and 34 are really close to each other. They have a difference of what? Difference of 1. Okay, so that tells me that my number, one of them is going to be 1. So how about we use a 35 and a minus 1? Okay, 35 and a minus 1. That is going to work. How do I know that? 35 times negative 1 is negative 35. 35 minus 1 is what? 34, which is what we need in the middle. So always look for things like the number in the box compared to the middle. If it's really, really close, like a difference of 1, then you're going to have 1 as your factor. Bless you. Now we can go ahead and split this up into 5a to the 4th. Then we've got a minus 35a squared, minus a squared, and a minus 7. Factor it now by grouping. And we're going to group the first 2 parts together. These have a 5 in common. And they also have an a. Now what's my smallest power? The lowest power of a is an a squared. So that's coming out. Always take out the lowest power in common. And if I take out a 5a squared, that leaves you then with an a squared minus 7. Wait, that should be a plus 35 there. My mistake. Sorry about that. That should make that a positive 7. I just copied it down because that should be a positive 35 and a minus 1. Right? Sorry about that. So factor the 5a squared. That's going to leave you then with an a squared plus 7. Now, how do we make it work with the next 2? Well, the next 2 components here, what do they begin with? Negative. It begins with a negative. What do you factor out? Negative 1. So that then leaves you with an a squared. Change your sign, plus 7. These are now the same. So a squared plus 7 comes out. Gone, gone. What's left over? 5a squared minus 1. How do I know I am finished? How do I know that I cannot go any further? I know I can't go any further because I look at my parentheses. A squared plus 7. 7's not a perfect square. This is a sum. Not going to do anything with that. That one's over. What about 5a squared minus 1? Can't be broken down as a difference of squares. Why not? 5 is not a perfect square. So I've checked everything out. And so now I know that we are done. And this is completely factored. That's as far as you can possibly go. So let's now look at a few more. I picked also, since we didn't ask any questions, I went ahead and picked 14 and 17. So out of 5, 4, question 14 I picked because this one is going to make you factor twice. Now, how do we know where to begin? Well, we know where to begin based upon the number of terms. We have 4 terms. So what we're going to try and do is we're going to try and group these together. Either grouping the first 3 together or the last 3 together, or 2 by 2. These look like I can factor out something out of both of these 2 here to make it work. Because I look at this and I say, okay, here, if I factor out an m cubed, see, that's going to leave me with an m minus 1. And that's very, very similar to this. Right? Because once you've done that, then you can see, oh, this is going to match up with that because this begins with a negative. So I'll factor out a minus 1. And that's then going to leave me with an m minus 1. Because that minus 1 will switch those signs around. Now what can we do? Well, now we notice that these are the same, which they should be. And now we've got m minus 1 and an m cubed minus 1. All the others that we've done today, we were able to stop at this step. This one has an additional step because we're not done yet, because look at what I've got underlined here. That is a difference of cubes. Okay. Always look for squares and cubes at the end. That's going to be a difference of cubes. Remember how the signs go for the cubes. They go. It's a difference, so it goes minus, plus, and then it always ends with a plus. So minus, plus, plus. M cubed, what is that? If we break it down, m times m times m, right? There's 3 of them there. What about 1? 1 is a perfect square and cube. So 1 is 1 times 1 times 1. So now we fill it in. So we take our m, we put it here, gone. What's left over? M times m, which is m squared. That's gone. Then we have a 1, right? What's left over? 1 times 1, which is 1. That goes here. What goes in the middle is those 2 put together, which is just an m. So we factored it by grouping. Then we factored out that difference of cubes. And now we can combine these 2 together because these are the same. And I can rewrite that as m minus 1 quantity squared, because there's 2 of them, times m squared plus m plus 1. And that is as far as you can possibly go. Any trinomial that comes off of a cube will never factor. So this part here is never, ever going to factor. So you don't even have to worry about that. We can't go any further because m minus 1 can't be broken down anymore. We put those together because there's 2 of them. So that made an m minus 1 quantity squared there. And I picked that one because that's one of the few where you have to factor. factor again. Question 17. Now there's a key word on this question we need to make sure we pick up on, and that's square. So it says the area of a square is given by this polynomial, okay, this trinomial here. We want to find the length of the side. So it's squared. What do we know about a square? Okay, on squares, the sides are the same, right? Now, what do we notice about this, specifically when I look at the 25 and the 64? What do you notice about 25 and 64? What is 25 and what is 64? They are what? What's special about 25 and 64? Does anyone know what to do? These are what? These are both. They're both squares, right? Okay. When you look at a trinomial like this, first thing you look for is, can I factor anything out? No, because this one doesn't have a y and this one doesn't have an x. Nothing's in common. Then I look specifically at the ends and I look for squares. We could factor it by taking the first times the last, but why do that and do all those extra steps and work with those large numbers when I notice 25 and 64 are squares? Because 25x squared can be broken down into 5x and 5x. So always look for squares and cubes. 64y squared. 64 is a perfect square of 8. So it's 8y and 8y. So this is what's called, again, a perfect square trinomial. You bring down your positive, because that's in the middle. And what do we have? 5x and 8y. This is squared. Okay, area of a square is two pieces put together. So that means the length and the width are both, because they're the same, are both going to be 5x plus 8y. And we could have took the first number times the last number. But what would have happened if you would have done that? Okay, if you would have took the first number times the last number, look at what you'd be working with. If you would have took 25 times that 64, that gives you 1,600. And you would have to find two numbers that multiply together to give you 1,600, add together to give you 80. And that would have taken a bit. We noticed that, hey, 25 is a perfect square, 64 is a perfect square, so why do all that work when we can just jump to our answer? Because this is, again, a perfect square trinomial. Last time we started 5, 5, and we got through about a quarter of 5, 5. So let's go ahead and look at some questions out of 5, 5 that I picked, just to kind of review some of these. And we can add more to the list too. So if you've got any that you'd like to have added to the list, we can add them once we get these done. So we're going to go ahead and look at 7, 9, and 18. And I picked those because those are the ones that we've covered, and they all illustrate a similar but different technique. So question 7 is 5x squared equals 5x. Now, this one is different than what we did in 5, 4. The difference is this one has an equal sign. If it has an equal sign, that means it is an equation, and that means you're going to get answers. If there's no equal sign, it's an expression, and you cannot get answers. So all the others, there was no answers, right? Because you can't solve it because there's no equal sign. This one has an equal sign. Now, what do we use? Well, the only technique that we are learning in this course is zero factor. When you get to college algebra, you'll learn, again, zero factor, but you'll add to that the quadratic formula, and you'll also add to that square root property, and also completing the square. So you'll learn some other techniques. This is just kind of getting you ready for college algebra. And the most commonly used technique in college algebra is this, is zero factor. So first thing we do is we set this to 0. Zero factor, pretty easy to remember. Set it to 0 and factor. Never ever divide. Do not divide both sides by an x or a 5 because you'll lose a solution. Now we should end up with 2 solutions because this is squared. 2 at most. We can't have more than 2. We may only have 1, but the most that we can have is 2. Now, what can I do? Well, from here, it's set to 0. Let's factor it. What do they have in common? They have a 5. What else do they have in common? They have an x in common. And if I factor the 5x, what's left over? X minus 1. Now, the hard part's already done. It's completely factored. Now, all we need to do is get our 2 solutions. This is one where students make a mistake with this 5x. That's why I picked this question specifically. 5x was factored out in front, so we've got 5x equals 0. A lot of times students will say x equals 5. X does not equal 5. 5x equals 0. How do you solve it? The 5's in front, so we solve it by dividing by 5. And 0 then absorbs it. So our solution would be x equals now what? 0, right? Not 5. I see a lot of times students get in a hurry. And they try to mentally do these and they make a mistake. Write it out so you don't make that mistake. What about the other one? Because we're going to get 2 answers, 2 solutions. Well, the other one is x minus 1 equals 0. How do we finish it? We add 1 to each side. And so that gives me my second answer to be x equaling now what? 1. So there are the 2 solutions. And we have 2 solutions because our highest power is squared. So that tells me at most 2. Question 9. I've worked out several of these. I want someone to tell me where to begin. If I gave you this question on an exam, this is something that you might see on an exam. You might see this on your final or something similar to it because there's a lot of factoring on your final and on your practice final. If I gave you this question and I said, solve this, it's already set to 0, what would you do? What would someone do? How would you begin?
First cry.
Okay. It's pretty easy looking though. What would you do first? You have to know how to do these. Does anyone have any idea? We can't take out 25t, but we can't take that out either. Before we do anything else, we look at these and there might be something in common. Is there something in common that I can look and take out at the very beginning? Not a number, but there is something else. T. Okay? So, we need to make sure we know how to approach a problem like this. The very first thing on any factoring is we look at all of them from a holistic standpoint, and we look and we say 25 and 64 have absolutely nothing in common, but they do have the same variable. They have the same variable, and that variable is a t. So that t has to come out. So the t comes out. And now we have 25t squared minus 64. How would I factor 25t squared minus 64? How would you work on this? Does anyone see what to do? I know we just did one with pretty much the exact same numbers, just a few questions back. Because I don't want to just do it all. I want you to actively participate and tell me where to begin, because you have to know how to do these. What would you do? Well, you can't do that. Okay, I want you to work with what I've got inside the parentheses.
Okay, so
and we look at the numbers.
Are 25 and 64 perfect squares?
Yes, they are.
Okay, so
Okay.
then you take out a 5 and an 8. Are you factoring?
Yep, well, you would factor, right? You're on the right track, okay? Yes, you were on the right track here. This is a negative, right?
Okay, right.
25 and 64, what are they? They are squares, okay? Use that table of squares and cubes. You can use that on your exam. We've talked about it many times. If you cannot remember your squares, your cubes, or you think, well, is 25 a perfect square? How do I know? If I don't know, use your calculator. 25, square root key. Is it a perfect square? Yeah, 5. Okay? If you can't remember your cubes or your squares, use a calculator. Check it, see if it works. Okay, 25, perfect square. 64, perfect square. Negative, so that means it's going to factor. Okay. Now, what do we know? What do we know about the signs? What goes in each one of these? Yep, very good. Okay, plus, minus, doesn't matter which one goes first. Just one of them's positive, one of them's going to be negative. What goes here? 5, okay, not just a 5, it's a 5, what? T, okay, and the same thing's over here. What goes here? 8, okay, and what goes over here? 8. So now we have this completely factored. What's our highest power? 3. At the very beginning, right, it was t cubed. So how many answers could we have at most? 3. What are we going to set to 0? This goes to 0, this goes to 0, that goes to 0. There's my 3 parts. Now, the first one, there's nothing really to do. So the first one, we factored out a t. So that's an automatic t equals 0. Anytime you factor out a variable, it's always equal to 0 at the beginning. So that one's done. That's one of them. Now, what about the other 2? What are the other 2? The other 2 are 5t plus 8 equals 0. You should have no trouble solving this, right? Okay, it's a linear equation. How do we solve it? Yep, move that 8 over, divide by 5. So move that 8 over with subtraction. Divide by your 5. And what does that give me then? It gives me t equals minus 8 fifths. There's 2 of the 3 solutions. So we did that one. We did that one. We've got one more. And the last one's going to basically be the same as the other one. It's 5t minus 8. So move the 8 over, in this case with addition. So then we've got 5t equals 8. And then how do we finish it? Divide it by 5. And what does that give you now? T equals a positive 8 fifths. There we go. We got all 3 solutions. Hopefully now you kind of see how you would approach a question like this. This is a similar question that you're going to see on your final and your practice final. A little bit different. It might just be something like question 7 that we did earlier. It might be a trinomial instead of a difference of squares. but something similar. What do you do to solve these? You set them to 0. You always then check to see, can I factor a number or a variable out at the beginning? That's the first thing you do. Then you look at the number of terms. So I factored that t out. That was my first step. Then I looked and I said, I have 2 pieces left. And those 2 pieces, what do we know? 25 is a perfect square. 64 is a perfect square. If you can't remember your squares, check them with a calculator. Every calculator has a square root key. If they come out to be a perfect square, there'll be a whole number when you use the square root key. So that was question 9. I also picked 18. '18 is one where they made a mistake. And we're going to talk about the mistake that they made. So I'm just going to copy down the question here, and we're going to have to find the mistake. And then I'll show you how to correctly solve this question. Okay, so this is what they gave you. They gave you these steps. So this is what you started with. Okay, so this is what we started with. We started with this. Then we went to here. We went to here. And then we finished it here. Now, where's the mistake at? First thing, I look at it, and I should have how many solutions? 3. Okay, how many solutions did I get? 2. So we're missing a solution somewhere. Where are we missing that solution at? Well, what can we never, ever do? You can never divide by an x, because what they did to get to this step was they divided by an x. When you divided by that x, you lost a solution, because when they divided by an x, that gave you 1 less solution. That's why they only got 2. Now, these are the 2 correct solutions, but there's also 1 more. And the mistake is here. You can never divide by the variable. If you ever divide by a variable, you will lose a solution when solving. So how do you make sure you don't lose one? You set it to 0 and you factor. Now let's look at how to do this one the correct way. So I'm going to work this one out the correct way. And I'm going to show you that you do in fact get 3 solutions. Well, the correct way of doing this would be to do what? What would you do first? This is 0 factor. So what would my first step be? Set to 0. Okay, we're on track with that. Now it's set to 0. What's my next step? Okay, what's in common? Yep, so what do? Take that out. That leaves you then with 81x squared minus 4. 81x squared minus 4. It has 2 terms. What do we know about 81 and what do we know about 4? What are they? Perfect squares. Okay? This is the difference of squares, isn't it? Right? 81's a perfect square. 4 is a perfect square. So that means we can factor it. bring our x down. One of these is positive, one of them is negative. 81 is a perfect square of 9, so that makes 9x and 9x. And what about 4? 2 and 2. One is positive, one is negative. Yep. Now, you should get 3 solutions. What are my 3 solutions going to be? This is the correct way of doing this question. First one equals, yep, done. There's 1. And you can put a check mark by them if you want to let you know they're done. So that one's done. Next one, 9x plus 2 equals 0. Move that 2 over. So 9x equals a negative 2. So x equals now a negative 2/9. I'm not going to write down all the steps because you can solve an equation. So that's done. And what about the last one? It is 9x minus 2 equals 0. 9x equals 2, which, again, same thing as what they had clear back up here, right? Right, that's what they got clear at this step. And then x equals now what? 2/9. There's your 3 solutions. One's positive 2/9, one's negative 2/9, right? And one is 0. What did they do here? They got part of them because they said, oh, these are our answers. But they missed a solution because they divided by the variable x. And you cannot do that with an equation. You can do it without one, with an expression, but with an equation you never want to divide by a variable because then what happens is you lose one of the solutions. Why don't we now go ahead and take a short break? We're going to come back and we're going to finish up 5-5 and then we'll look at our practice final. So let's take about a 15-minute break and we'll meet back here at 9:35 and we're going to finish up 5-5 today. Not that much left in it.